What's the product of the reaction that is shown below? We have an alcohol halide reacting in a series of reaction. First, it has been reacted with triphenylphosphine, and the product that is obtained is reacted with N-butyl lithium, and then finally the product here has been reacted with carbonyl compound. Now let's go find the products at each step. When we have an alcohol halide reacting with a triphenylphosphine, then we can definitely say that it is going to undergo SN2 reaction because the triphenylphosphine is going to act as a nucleophile onto this carbon. More like a nucleophile acting on an SN2 reaction, thrusting out this Br. So let's write on the product for that reaction. So this triphenylphosphine is going to make a nucleophilic attack on this carbon, thrusting the Br out. We'll get an intermediate that is going to look like this. And here, these two hydrogens right here is going to be acidic. So one of these hydrogens can be easily pulled by a strong base such as butyl lithium. So when you react it with butyl lithium, one of these hydrogens right here is going to be pulled by the butyl lithium. So let's separate the hydrogen here. Butyl lithium is going to go and abstract this hydrogen, and it's going to push those electrons onto carbon. This is going to basically form the halide, which is going to have the structure. Now this halide is going to have another resonance contributor where these electrons right here is going to be pushed on here to form the double bond between carbon and phosphorus. Now, so let's identify the products here. So this, let's say that this is going to be A, this is going to be B. A is going to be this intermediate and B is going to be this intermediate, right? Or it could also be this because we are taking the resonance contributor. Now we have an halide that has to be reacted with a carbonyl compound. When an halide reacts with a carbonyl compound, what we get is an alkene, and this we call as Wittig reaction. Let's take a look into the Wittig reaction. Here is the Wittig reaction where you can see that when you have an aldehyde or a ketone reacted with phosphonium halide, what happens is these two groups are going to get switched. Okay. This is going to get switched with the triphenylphosphine group here. So basically it is going to form the alkene. Now let's apply this for a reaction here. We have an halide reacting with cyclohexanone. So what happens here is this is your R group. The R group and the triphenylphosphine group is going to get exchanged. Here, the formed alkene would be this, okay, which is option D. That would be the right answer. In the Wittig reaction, we are not forming an alcohol, we are not forming an ether. Instead, we are forming an alkene. So between these two alkenes, this is the right structure because we have the double bond in the right place. The double bond is going to stay in place.